Hey everybody, it's Book of Catherine. I hope you are doing well. I am. You know I'm doing way better because I am actually able to write my name, right? So I have learned a whole bunch of things since I have talked to you guys last, and the first one I want to talk to you about are what's called X points. And X points are something that if you're involved with the space industry, you know about, but they actually should be on the Weather Channel. You guys are affected by X points almost every day, especially when big planets are around, and they are a major contributor to our health. And so I'm going to go ahead and let you know about those, and hopefully one day our weathermen will pick them up. So it turns out that there is, if you say that there's Earth, it turns out that Earth has this giant magnetic field, which I'm sure you may or may not have heard about in school. And they used to say that that was attributed to our iron core, but it turns out that that's not actually the case. It turns out that Earth doesn't have an iron core. It actually has a mushy core made of a bunch of stuff. So they're only just learning what that is. Now, Earth has a magnetic field that doesn't just look like this. It looks like it has a big, huge shield around it. And that shield has been formed by the sun. When this magnetic field is hit with solar winds, basically we have the Earth here, and it has its little magnetic shields going on, right? And then we have the sun, which is super huge, and it's got all this big brightness coming out of it. The sun is always shooting what's called solar winds at us. In fact, they're shooting at it everywhere, at the entire solar system, right? So they're constantly going, and depending on how fast these solar winds are going, they'll impact this huge shield that our atmosphere has, and it blows the atmosphere and even the magnetic sphere's tubes, the flux tubes they're called, it even blows those back. So what we've learned is that the sun itself has its own magnetic shield or magnetic field. It has its own flux tubes. But because it's 93 million miles away, it doesn't necessarily always affect us. What happens is sometimes a nearby planet comes along that's much bigger than us. Like there's Earth, and then there's Jupiter. It's much, much bigger. Now the sun is bigger than all of us, but Jupiter is super huge. And Jupiter doesn't have an iron core, but Jupiter has a much, much bigger magnetosphere than Earth's. And if it's spinning nearby us, it actually intersects with our own magnetosphere. We're sitting here with a little magnetic sphere and all these magnetic poles going on. And if Jupiter comes by, and Saturn, which is also pretty big, what can happen is our magnetic fields can interact and actually touch and cross with each other. And what that's called, when one of these interacts with each other, like right here, it forms what's called an X. Or an X point to be precise. It forms an X point. Not a very, how should I say, imaginative term, just very, very practical because it looks just like an X. Now, that might be all fine and good. You might think, well, okay, so our magnetic fields interact. What's the big deal about that? And the big deal about that is that if the sun is sending us solar particles, usually the sun takes, because it's 93 million, well, it was 93 million miles away from Earth, we didn't really have to worry about a big solar flare hitting us for 3 days because we're so far away. But if we have an X point nearby, let's say, I don't know, Jupiter's over here, not Jupiter, sorry, but let's say Venus is in front of us, and Venus has its flux tubes, and it just happens to be near us. And then Earth is sitting here like this, and our flux tube actually crosses right here. Well, Venus is closer to the sun. Here's the sun emitting all of its solar rays. And if the sun hits one of these flux tubes, it moves faster along a flux tube. So when it gets to this X point that's right here, what will happen is that it'll just skip the line and reach Earth earlier. And so it changes these 3 days turns into minutes. So if a massive solar blast comes our way and we just happen to be near Venus or happen to be near Jupiter with this massive magnetic field that hits that happens to get near the sun earlier than us and hits an X point, it'll slam us much, much sooner. I'm hoping you guys can understand this because I wrote it all in black. One day I will get good enough. I'll become healthy enough to use a bunch of different colors on you, and it will not scramble my brain. You would think that this would scramble my brain, but my head's been getting a lot better. For those of you who don't know, I have functional neurological disorder, and I have a very severe case, so it has taken a lot of physical therapy and a lot of occupational therapy to be able to hold a pen and write with it. So I'm very excited that I'm able to do this for you. So if we have Venus, and it also has, and it turns out these magnetic fields of ours are actually based on the size of the planet. Venus is pretty similar to us. So we have like the same size magnetic fields. But remember, Venus has this huge tail going on. So if it's near us, its huge tail comes and gets pretty close to us and helps the sun that hits it on this side over here when the solar wind hits it. Man, it can just speed up very, very quickly and get to Earth much, much more quickly. So in short, you will notice that there is more volcano activity. There is more, so you'll see an increase in volcanoes. When an X point, when a solar flare has come, or when there are big planets nearby, I know like December 20th, if you look it up, December 20th, we had a big jump in volcanic activity and also earthquake activity. So the reason why we finally discovered is because on around December 20th, we had the Great Conjunction. Woo! And what happened is that all these planets lined up. We had Venus, and then we had Earth, and then we had Mars, and we had Jupiter, and we had Saturn. And there was this massive conjunction where we all lined up, and you can just imagine how all of our magnetic fields were just tied in at once. They were overlapping between each other. And so all of the sun's energy just swapped and interchanged all over the X points for all of these planets. And the reaction on Earth was just, we had major eruptions in Hawaii. We had major eruptions in Italy at Mount Etna. Italy's Etna went off. Kilauea went off. Also, Pacayas began kicking up over there in Guatemala. So it's all over the world that we saw volcanoes kick up. And it turned out that all of our magnetic fields were interacting and bringing all this sun that was over here blasting at us. It helped transfer it at very, very quick activities. And then 3 days later, we'd still get hit with the plasma that would normally reach us. And so we're getting a double whammy. Now, you may be asking, well, what does that have to do with our health? Well, the problem with that is that when it comes to solar activity, what it is it's a bunch of charged particles. These little atoms are coming at us from the sun with who knows how many different things, right? They're coming at us, and they have these positive and these negative charges. And what happens is they fly at us super fast, and when we are bombarded, it's called a sunstorm. Now, normally, we used to be protected from sunstorms by our magnetic field. We used to have this magnetic shield, and it protected us from it. It would bounce off, it would hit here, and it would just get waylaid out here into the tail, right? It would go, boom, and it would just fly out past us. The problem is that we've had a depleted magnetosphere, and that depletion rate has been declining since Christ, it turns out. So there's been this, like, when the cross happened, the magnetosphere started dying. Well, oops, you can't see that. So the magnetosphere started dying. Well, what happened is in 2015, it started dying at 10 times the rate. So it just plummeted off. It just went straight down. And so what's happening now is that all these sunstorms that are totally normal for the sun, they are happening, and we are only protected like this much. We've had like a 40% decrease. And so our shield is like only this big now. And so we still have our magnetic tubes and everything like that. It's been worn down. And for whatever reason, there's all sorts of reasons they suspect, but we don't have the same size of magnetosphere we once did. It's gone down by about 40%. And so what that means is the sun is affecting us in a much, much greater way than it once was. So, of course, that's a lot of UV radiation. Let me give you an example. So the UV radiation that's happening is, there were March readings. Actually, it happened in January and February and March up in North America. North America was registering double the rate of UV radiation from the sun than it normally lives. So if we were expecting a UV radiation rate of, let's say we were supposed to get 4.5, a 4.5 reading of radiation, we were getting instead a 9 reading on the radiation scale, on the UV scale. And so that's the stuff. The UV scale is what we protect against when we wear things like sunscreen. So what happens when it hits us and we don't know? Because, of course, they're not telling this on the weather station and the health professionals aren't telling us. So what is happening? We know that heart failure, heart disease, heart problems go way up. Like heart problems go way up. We know that depression rates go way up. And so if there are addictions that drive depressions, those addictions tend to go way, way up. So heart problems end up happening, and also things like migraines, things like that, those go way up. And so another big one is fatigue. Goes way up. And then also stress. And that's because we have a bunch of radiation hitting our body that we are not expecting. And one of the big ways that you guys noticed this happen, there's a whole big following on the social medias about this, was what was called the magnet challenge. And if you paid attention to the magnet challenge, people thought it was the vaccine, but it wasn't the vaccine. And the way we knew this, it wasn't the vaccine. The way we knew that it was the sun is that the people who had the most amount, what's happening is that the sun is coming down and ionizing the blood cells, right? And when you ionize it, then it becomes more magnetic. So what happens is that if you start paying attention, I posted some of these on Twitter. You can go ahead and search my feed for it. Go on Twitter and look up at Book of Catherine. On Twitter. And if you just look up Magnet Challenge, I have a whole host of videos that show you the Magnet Challenge. If you go ahead and look that up on Twitter, on the search bar on Twitter, and search Magnet Challenge, you'll find a whole bunch of videos. And what you'll notice with the videos is that the magnets only work in areas exposed to the sun. So like if a girl is wearing a tank top, right? The magnets will only fit on her arms, or it's only on her chest, or on her face. But if she goes and pulls the sleeve off, then it doesn't work. Same thing is, there's a video that I have on there where a daughter was saying, oh, we went out to the sun, and her mom, you know, had these shoulders, beautiful shoulders, and she was just wearing a tank top that went like this, you know, just one of those basic tank tops. And they had just been out to the pool, and she was able to fit all these spoons, you know, and cutlery, forks, and knives. She was able to fit that along her shoulders, right? Wherever she had just been out the sun like literally 15 minutes before. So the sun is definitely affecting our health. Like if anyone, go ahead and take a look at that Magnet Challenge. If you think back, it was always on somebody's forehead. And it was people, remember, there are people who are saying, I didn't get the vaccine. So they were not happy about it. But they're able to fit things, metal objects to like their forehead, right? They're able to stick a fork on there or a knife on there or paper clips on there. So they're able to just put a little paper clip on their forehead, but they hadn't had the vaccine. And so that's part of the thing, is that that's a place that's highly exposed to the sun. So the sun is affecting us more than it ever has. And the X points will take a big solar flare that goes whoosh and off the planet. And whether it's hitting us or not, when it hits Earth, it usually takes 3 days and has time to like slough off everywhere. But if it's an X point, if X points are anywhere nearby, it'll speed up and hit Earth in an amount of minutes. And it'll hit Earth hard. That just happened last Friday, the last Friday of March. We got a really big slam from a really giant solar flare. Last Friday of March. I don't know if you can see this. Make sure. 2022. Sorry, guys. I'm getting used to this. So if you remember that day and if you had a hard time with health and anything like that, make sure to just stay out of the sun. And if you can, please wear please wear some sunscreen if you have to go out into the sun, and definitely wear UV sunglasses if you can. This is just if you can, but make sure, just know that the sun is coming at us much harder. An example is that, you know, we are the Earth, and the sun just started hitting the northern hemisphere, right? Because it was the spring equinox, right? So on the spring equinox, right afterwards, is hit the northern hemisphere. So what's supposed to happen is the southern hemisphere is supposed to get colder, right? That's what everyone expects, is it to get colder. But in 2022, this year, it did not get colder. In fact, what happened is at the South Pole, it went up. When the sun left and went to the northern hemisphere, it went up 33 degrees Celsius. The South Pole heated up 33 degrees Celsius. And that's not supposed to happen. It's supposed to get colder. And instead, it got much, much warmer. In fact, it heated up so much that it hit 33 degrees above the average temperature. It's supposed to be minus 50 degrees over there Celsius. And instead, it registered a negative 17 degrees. And so that is a really big deal. Things are really, really heating up and the sun's getting much harder. I remember the last reading for the year 7000 that I saw, we were supposed to have a UV rating right around, I think it was somewhere around the 20th of March. And the reading was supposed to be 6.5 because we were just changed into spring. And instead it was an 11.5. And this is in the extreme category. 11.5 goes into extreme, where you're going to get bad. This is all for UV rating. So this is when you get bad burns, right, that cause cancer. So just make sure that you're keeping yourself aware of health, and share this video if you can, or make your own video with better graphics if you'd like to. But that is my best shot at helping you guys with what X points are and how they affect your health. So I hope that helped out a lot. I love you guys so much, and I'll see you guys on the next one. Hit subscribe if you can. You want to catch the next cat video or the next video that I do about things you need to know that they aren't talking about on the mass media publicly traded stations. All right. Love you guys so much. Bye.